Integration by parts 3. Here we have integral e to the 2x sine of pi x dx. We will let u be equal to e to the 2x, dv be equal to sine of pi x dx. Let's write that down. U is equal to e to the 2x. Its derivative du is equal to e to the 2x times 2 dx. The reason for the 2 is the chain rule, of course. We have to differentiate the exponent. dv is equal to sine of pi x dx. Integrate both sides. We get v is equal to negative cos of pi x divided by pi because of the chain rule. Apply the formula u times v, that's e to the 2x times negative cos pi x divided by pi minus integral v, that's negative cos pi x over pi times du, that's 2 e to the 2x dx. So we get negative 1 over pi e to the 2x cos of pi x plus 2 over pi integral e to the 2x cosine pi x dx. Okay, let's see what we have here. We have I is equal to minus 1 over pi e to the 2x cosine of pi x plus 2 over pi integral e to the 2x cos pi x dx. Important note, since u was chosen to be the exponential function e to the 2x in the first application of the integration by parts formula, we must choose u equals e to the 2x in a second application of the formula. Otherwise, we will go in circles. So we're going to apply integration by parts again to this part. Okay, let's do that. So we have integral e to the 2x cosine of pi x dx. Let u be equal to e to the 2x, du is equal to e to the 2x times 2 dx. dv is equal to cos pi x dx. And to differentiate both sides, we get v is equal to sine of pi x over pi. So this part is u, and this part is dv. Apply the formula, that's u times v, e to the 2x times sine of pi x over pi minus integral v, that's sine of pi x over pi times du, that's 2 e to the 2x dx. So we get e to the 2x times sine of pi x over pi. Let's pull out the negative 2 over pi integral e to the 2x sine of pi x dx. Now notice this is exactly what we were looking for. So let's rewrite what we started with. On the first page we had this integral. I is equal to negative 1 over pi e to the 2x cos pi x plus 2 over pi times integral e to the 2x cos pi x dx, which is solved here. So let's rewrite this. I is equal to negative 1 over pi e to the 2x cosine pi x plus 2 over pi times e to the 2x sine pi x divided by pi minus 2 over pi times, this integral is exactly what we're looking for, so I'm going to call this I, minus 2 over pi times I. Now let's simplify this. We get I is equal to negative 1 over pi e to the 2x cosine pi x plus 2 over pi squared e to the 2x sine of pi x minus 2 over pi times 2 over pi minus 4 over pi squared times I. Bring this term over, we get I plus 4 over pi squared times I is equal to negative 1 over pi e to the 2x cosine pi x plus 2 over pi squared e to the 2x sine pi x. Let's factor out the I times 1 plus 4 over pi squared is equal to negative 1 over pi e to the 2x cosine pi x plus 2 over pi squared e to the 2x sine pi x. Now we get the answer. Let's divide both sides by 1 plus 4 over pi squared. We get I is equal to negative 1 over pi e to the 2x cosine pi x plus 2 over pi squared e to the 2x sine pi x. Let's bracket this. All divided by 1 plus 4 over pi squared. Notice how the integral e to the 2x sine pi x dx reappeared in the process of solving this question. This is the recursive nature of this sort of problem. See you next time. I need to make a correction. In this question, we're solving an indefinite integral. There are no limits of integration. So the answer should involve plus c. We have to add a constant of integration at the end. Thanks.